Hello Year 11 and welcome to our next video here, the sums and products of roots. Now we have used the terms roots and zeros of a polynomial largely interchangeably up until now, and I don't really think we're going to change that too much. Now we're not here necessarily going to find the roots of a polynomial, but we're going to investigate some of their properties such as their sums, right, where we add them together, or their products where we multiply them. We are generally going to refer to these roots with the Greek characters, lowercase Greek characters, alpha, beta, and perhaps gamma. Right, that's probably it. Probably won't go any further than that, any more than cubics. And we're going to begin with quadratics. So in simple terms, the sum of the roots of a quadratic. Okay, so that's alpha plus beta, where alpha and beta are the roots. Alpha plus beta equals minus b over a. That is the coefficient of the second term divided by the coefficient of the leading term. Right? If we write it out like this, minus b over a is the sum of the roots. You pretty much just got to remember that. Now the product of the roots, alpha times beta, is c, not negative c over a. So for the time being, remember this. For a quadratic, the sum of the roots is minus b over a. The product of the roots is c over a. Here we go. An example, we have a quadratic here. Alpha and beta are the roots. What is the sum of those roots? Alpha plus beta is, remember, is negative b over a. So that's negative 6, or 6 over 2 equals 3. Okay. Alpha beta, right, the product of the roots, c over a, is 1 over 2. Now, alpha squared plus beta squared requires a little bit more creativity here. Well, that's the same as, can I say it's alpha plus beta, I'm going to complete the square here, minus 2 alpha beta. Okay, completing the square, and I get alpha plus beta, which was 3, squared is 9 minus 2 lots of 1/2. That's 9 minus 1 equals 8. Rightio. And finally, 1 over alpha plus 1 over beta. Now, these seem a bit complicated for the time being. How do we go about solving these? Well, you find there's really only so many questions. You become a bit familiar with them after a while. What we're going to do here, because we're adding fractions together, we're going to find equivalent fractions with a common denominator, and that gives us beta over alpha beta plus alpha over alpha beta, which gives us alpha plus beta over alpha times beta. Gives us alpha plus beta is 3. 3 divided by 1/2 is the same as 3 times 2 equals 6. Now, sums and products of roots of a quadratic, pretty straightforward because there's only, there's only those two roots. We're going to move on now. Oh no, we've got another example, but we introduced some different variable in here. Now it says to find k. We're not finding the roots. Okay, we've just got this this constant, this variable in here, k, is thrown in the mix. I want to know what it is. Well, I've got a quadratic and I'm told what one of the roots is. Well, right, alpha equals negative 2, and we also know that alpha plus beta is going to equal negative b over a. So that is 7 over k. Therefore, remember alpha is negative 2. Right. I'm going to say beta minus 2 equals 7 over k. Or, let's say beta equals, let's just leave that for the time being. Oh, that's the wrong button. Okay, we've got this. Not solved. We've got some more tricks up our sleeve. I also know that alpha beta, right, equals c over a. Now that's k plus 1. Over k. What are we going to do here? Well, I think if we do this, now I'll substitute my negative 2 in. Negative 2 beta is k plus 1 over k. And I'm going to shuffle this around and say that beta equals, now, I'm going to say it is negative outside of k plus 1 over 2k. Now I'm going to substitute that beta in over here, and I'm going to say negative k plus 1 over 2k minus 2 equals 7 over k. Okay, I've substituted this into this beta here. Multiply everything by, I think, a 2k, and I get negative k minus 1. Now, multiplying by 2k gives me minus 4k equals 14k. No, sorry, just equals 14. Okay, multiplied throughout by 2k. Now, what does this give us? Negative 5k equals 15 means that k equals negative 3. There we go. Popped out there at the end. So we used both of those properties to generate a couple of equations which we could solve simultaneously. Here we go. There's another one. Find the value of p if one root is double the other. Well, I'm going to say let alpha equal to beta. Okay. The roots are alpha and beta, and alpha is twice as big as beta. So now we know that alpha plus beta is going to equal 2 beta plus beta equals 3 beta. Also, alpha plus beta is minus b over a. Now, is negative 2. Therefore, 3 beta equals negative 2. Beta equals negative 2/3. What else do we know here? I also know that alpha plus beta. Oh yeah, so alpha equals 2 beta. Therefore, alpha equals negative 4 over 3. And that's it. Rightio, now I could have a look at what happens with the product, right? Alpha times beta. That's going to be the same as 2 beta squared, right? It's going to be 2 beta squared, and equals c over a, but really we're just going to end up with the same answer there, right? Negative 4 over 3. Now that would be all well and good if we were asked to find the roots, but we're not. We're asked to find the value of p, which as yet is unsolved. So what are we going to do? Well, we only use this product now. I'm going to say alpha beta equals, now that's negative 2/3 times negative 4/3, and it's also equal to, right, c over a, that's negative 5p over 1. We'll tidy it up a little bit. Therefore, 8 over 9 equals negative 5p. Therefore, p equals, divide both sides by negative 5, I get negative 8 over 45. Rightio, solved. Be careful that you answer the question. Very nearly stop there after finding alpha and beta, after finding the 2 roots. Now for cubics, it gets a little bit more complicated. So the sum of the roots, that's alpha plus beta plus gamma, right? Alpha, beta, and gamma. The sum of those is equal to minus b over a. Alpha, beta, so the sum of the pairs, right? The sum of the pairs, that's alpha, beta plus alpha, gamma plus beta, gamma, right? That's this one here. The sum of the pairs equals c over a. And the product of all 3 roots is negative d over a. So negative b on a, positive c over a, negative d over a. Let's have a look here at the examples. Alpha and beta are the roots of this. Oh, yeah, well, that's 2 of the roots. Now, alpha, beta, and gamma, I'm sure that really needs to say, and gamma are the roots of this equation. Find the sum. Okay, the sum of the roots is equal to, right, negative b over a. Now, what's b? Well, be careful here. This is the same as 3x squared plus 0, oh, sorry, cubed. 0x squared minus 6x plus 1 equals 0. So a equals 3. B equals 0. C equals negative 6. D equals 1. Just be careful there. So, the sum of the roots is negative b on a is negative 0 and 3 equals 0. The product of the roots is equal to negative d over a. That's negative 1 over 3. And the sum of the pairs right, is equal to C over A, that's negative 6, oops, over 3 equals negative 2. Now, whoops, just as we've had before, some complications here. The square of the sum, well, that's fine. I know what the sum is, so the square of that is 0 squared equals 0, no complications. What about this? Well, once again, to add our fractions together, I'm going to say this is, I don't have a lot of space, it's going to be alpha beta plus alpha gamma plus beta gamma, expand it out if you like, over alpha beta gamma. Rightio, we're going to find equivalent fractions with common denominator, and that equals, right, the sum of the pairs is negative 2 over the product, negative 1 over 3, and that just equals 6. Now what do we do here? Alpha plus 1, beta plus 1, gamma plus 1. Look, I think if we expand this out, I'm going to say it's alpha plus 1 outside of beta gamma plus beta plus gamma plus 1. Expand it out again, and I get alpha beta gamma plus alpha beta plus alpha gamma plus, I'm going to bring that beta gamma in just so we can see it there, plus alpha plus beta plus gamma plus 1. Oops, don't need that last bracket there. Okay, so I've got the product, which was negative 1/3. Right, plus now this part here, so sum of the pairs, right, and that was equal to negative 2. And this part here is equal to 0, right, sum of the roots, and then plus 1. Now, negative third minus 2 plus 1, that's same as negative 1/3 minus 1, that's negative 4 over 3. Rightio? There we go, like that. Some more examples here. If this has roots alpha beta gamma, find the value of alpha cubed plus beta cubed plus gamma cubed. Now, if they were squared, I'd try to sort of work this sort of by completing the square, doing something a bit like that, perhaps. But been down that path, it's not pretty. No, consider this. Polynomial of alpha, right? Alpha's a root, equals 2 alpha cubed plus 5 alpha plus 1. And it equals 0. Yeah, because it's a root. Now, if I rearrange that, I can say, therefore, negative 2 alpha cubed equals 5 alpha plus 1. Similarly, polynomial of beta equals 2 beta cubed plus 5 beta plus 1 equals 0. Therefore, negative 2 beta equals 5 beta plus 1. And also, negative 2 gamma equals 5 gamma plus 1. Therefore, negative 2 outside of, oops, cubed, forgot my little cubes here, alpha cubed plus beta cubed plus gamma cubed. Right, I'm going to add those three equations together, and I've just factorized a little bit, taking the negative 2 out, equals 5 alpha plus 5 beta plus 5 gamma plus 3. Right, that means that alpha cubed plus beta cubed plus gamma cubed equals 5 outside of, actually I'm going to say negative 5 over 2 outside of alpha plus beta plus gamma minus 3 over 2. Now, alpha plus beta plus gamma, remember that the sum is minus b over a, and b equals 0. So this equals negative 5 over 2 times 0 minus 3 over 2. So my answer is simply negative 3 over 2. Sorry, got a little bit scruffy there, a little bit tight. but certainly that is the fast and easy way out of this. Finally, I think, is this the last one? Nope, it's not. Find the cubic whose roots are twice those of this. Well, if that's the case, let alpha, beta, and gamma be the roots of 2x cubed minus 3x squared plus 1 equals 0. Therefore, the roots of our unknown equation are going to be 2 alpha, 2 beta, 2 gamma. Right, so I'm going to say if alpha plus beta plus gamma equals, equals minus b over a equals negative 3 over 2, then 2 alpha plus 2 beta, double the roots, plus 2 gamma equals 2 times negative 3 over 2 equals negative 3. Okay, therefore my negative b, I'm going to say, I'm going to use capital B here for my coefficient of the bigger equation. So minus b over a, negative b over a, no, let's just stick with this, equals negative 3. Right, partway there. Next step we're going to look at here is 2 alpha times 2 beta times 2 gamma is equal to, careful, that's a times, not a plus, equals 8 outside of alpha, beta, gamma, right? Because it's double each of them, so it's 8 times the product, and that equals 8 times d over negative d over a times negative 1 over 2 equals negative 4. So therefore, negative d over a equals negative 4. Right, 2 parts done. We've only got one more to go in the last. Well, this next bit's going to be pretty straightforward. Now, 2 alpha beta, 2 alpha times 2 beta plus 2 alpha times 2 beta plus 2 beta times 2 gamma. Right, this should be a gamma here. Right, that's equal to, rapidly running out of space here, equals 4 outside of alpha beta plus alpha gamma plus beta gamma. Righto, equals 4 times, now, c over a. C is the coefficient of the x term here, equals 0, 4 times 0. Therefore, c over a equals 0. Now, I'm going to wrap all this up. I'm going to say, let a equal 1, for b equals 3, d equals 4, c equals 0, therefore x cubed plus 3x squared, right, now there's no x term, plus 4x, plus 4, didn't really need to do that, plus 4 equals 0. That is our cubic with double the roots. Rightio. So what we looked at was you don't just sort of double each of the bits. That double the that if I have the product of all 3 roots, it's going to be 8 times as big because they've all been doubled. Now I'm only going to talk very quickly here about quartics because we're hitting the magic 20-minute mark. Alpha, beta, gamma, delta. Right, minus b over a, positive c over a, minus d over a, positive e over a. The pattern continues on and on. Quartics just tend to get a bit out of hand, a bit big. Cubics is probably where most of the work with these is, and with the quadratics, they're pretty straightforward. So cubics is the sweet spot, hard but not too hard. Rightio, that's it. That sure is a lot. Shoot me a message because I won't be in class for a week. Shoot me a message if you've got any questions, and I'll get back to you as best I can.